Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? Yesterday I think we have described the multiple choice question, probable question which may appear in your exam based on chapter number 1. The name of that chapter is polynuclear and the heteronuclear aromatic compound. The details of that chapter as well as probable multiple choice question we have discussed by looking forward the probable third wave of COVID-19 pandemic, and that's why we have extended we spend some of the time on multiple choice question. So I hope you might understood that chapter in a well manner, and now today at present what we are going to discuss, we are going to learn the chapter number 2 according to the new revised syllabus which is implemented from 2021, and it is a CBCS credit based choice system 2019 pattern, and therefore from this year T.Y.B.Sc Savitribai Phule Pune University introducing this new syllabus, and which is a very important as far as your future perspective is considered. So let's begin with chapter number 2. The name of that chapter is reactive methylene compounds, or we can call it as active methylene compounds. So in the general introduction, what do you mean by the active methylene compound, or how do you define the active methylene compounds? In active methylene compounds are of great importance in synthetic chemistry. For example, diketones are important starting material in many organic reactions, many organic synthetic reactions, particularly in perfume and cosmetic industries, as well as in pharmaceutical industries or agro industries. So these are the compound have wide range of application in the different fields, and few of them I have already mentioned over here. When CH2 group, let's see this one, this group is known as reactive methylene compound, reactive methylene group, or what we can call it as active methylene group. When we can call it, because number of organic compound containing as a CH2 group, no doubt about it, methylene group, millions or the trillions of the organic compound which containing as a CH2 group, no doubt about it, but what kind of the compound are generally termed, or generally they have active methylene group or reactive methylene group, and that compound are referred as active reactive methylene compounds or active methylene compounds. When CH2 methylene group is flanked, remember, is flanked, when CH2 methylene group is flanked between two electron withdrawing group, between two electron withdrawing group, that EWZ is generally termed as electron withdrawing group or electron attracting group. And it is known as active methylene group. When the CH2 group is flanked between two electron withdrawing group, let us see here EWZ and then CH2 EWZ, this group is known as reactive methylene group or active methylene group, because these EWZ is nothing but as a electron withdrawing group. That is the full form of that EWZ, electron withdrawing group. On both the side, if such kind of groups are present, and that CH2 group is generally termed as active methylene group or reactive methylene group. And if such electron withdrawing groups are not present adjacent to that CH2 group, and that compound or that methylene group do not considered as a reactive methylene group, that you remember. When on both sides there is a electron withdrawing group such as carbonyl group, nitro group, cyanide group, ester group, aldehyde group, such compounds are present on both sides of that CH2 group, then and then that group is generally termed as a reactive methylene group. When CH2 group is flanked between a two electron withdrawing group, it is known as a reactive methylene group or active methylene group. Or the class of compound which contain methylene group directly attached to the electron withdrawing group is termed as reactive or active methylene group. See the alternative definition for active methylene group or reactive methylene group: the class of compound which contain methylene group directly attached to electron withdrawing group is termed as reactive or active methylene group. And remember here, this group is generally termed as a reactive or the active methylene group because it has two electron withdrawing group adjacent to CH2, and therefore this CH2 is known as reactive methylene group. It is known as a reactive methylene group. Reactive methylene group. Let's see, suppose we have this one CH3, then CH2. Then let us see CH3 once again. Here, if you see this compound carefully, everybody know that it is a hydrocarbon, a aliphatic hydrocarbon. Hydrocarbon means what? The compound which is made by carbon and hydrogen atom are known as a hydrocarbon. Even though these compound containing as a CH2 group, means methylene group is present in this compound, but it does not considered as a reactive methylene group. Why? The essential and the necessary criteria when to call CH2 group as a reactive methylene group or the active methylene group, when it is present in between two electron withdrawing group, then and then we can call it here. Here is a methyl group which is act as a electron donating group, and on other side also methyl group which is also acting as a electron donating group, and therefore this methyl group, even though this compound N-propane has a CH2 group, but this propane group does not considered as a reactive methylene group, because that CH2 group is present, no doubt about it, but it is not present in between as a two electron withdrawing group, and therefore this is not containing as a active methylene group or the reactive methylene group, and therefore this compound is not belonging to the reactive methylene compounds or the active methylene compounds. See here, the hydrogen atoms of CH2, look at here, hydrogen atoms of CH2, there are two hydrogen atoms present or attached to that carbon atom which is flanked between a two electron withdrawing group, becomes more acidic in nature and can be replaced easily. If you treat these such kind of the compound with a strong base, and after the deprotonation, whatever the carbanion form, that carbanion are well stabilized due to the minus I inductive effect and the minus R inductive effect, minus I and the minus R effect of carbonyl group generally, or maybe a nitro group or a cyanide group, and therefore minus I inductive effect and the minus R inductive effect you already learned. These are the structural factors or the electronic effect which can either decide the physical properties of the organic compound, the reactivity of the organic compound can be assigned, can be decided by these electronic factors, inductive effect and the inductive effect and the resonance effect. These are the electronic factors which are useful for deciding or for determining the reactivity of the organic compound, and these factors we already learned in our previous classes such as T.Y.B.Sc. Now you are at T.Y.B.Sc, and therefore I am not going to go details of those factors. I am just giving you you can refer the T.Y.B.Sc textbooks, and from that you can clear your ideas regarding that. inductive effect and the resonance effect. And these compounds are useful synthetic intermediates. Remember why we are discussing these reactive methylene compounds are the active methylene compounds. The main use of these compounds, they are very important as far as synthetic intermediate is concerned. And some of the example of active methylene compounds are, here we are going to discuss few of the example which containing reactive methylene group, their synthesis as well as their application in chemistry that we are going to discuss here. And some of the example of active methylene compounds are diketones. Examples of active methylene compounds are examples. Let us see one of the example is the diketones. Second would be ethyl acetoacetate, ethyl acetoacetate, or it is termed as acetoacetic ester, or it is also known as beta keto ester. These are the different names given to that. Third one may be as a diethyl malonate, or what we can call it, it is also known as malonic ester, and the fourth example of this compound, cyanoacetic ester, that is a cyanoacetic ester, cyanoacetic ester, malononitrile, and fifth example may be as a malononitrile. These are the example of some of the reactive methylene compounds, and which compounds generally has electron withdrawing group in them. Diketones, generally I am showing here the structures of diketone. There are the various diketones are present like this. Then R C double bond O, CH2 C double bond O, R, then R C double bond O, CH2 CH2, then C double bond O, R. Remember here, diketone, there are the various forms. General forms I have shown on the blackboard. Look at here, 1 and 2 position. So this is this is generally as a carbonyl group. Adjacent carbonyl group is generally termed as alpha. So this you can call it as alpha diketone, and this one is alpha, and this one you can call it as a beta diketones. This you can call it as alpha, beta, gamma diketones, delta diketone, and so on. But remember, which of the diketone belonging to reactive methylene group, or which of the diketone is important here? Those diketone which has reactive methylene group in them. Look at here, there is no reactive methylene group present here in diketone, but here, look at here, there is a CH2 group is present, and therefore this would be the reactive methylene compound. Here are two CH2. On one side is there, but other side CH2 groups are there, and therefore it does not contain reactive methylene compound only. Out of that three, this would has a reactive methylene group, and therefore it is important as per as what we can call it as a reactive methylene compounds are concerned. Now ethyl acetoacetate, acetoacetic ester or beta keto ester. Here let me draw the structure of this compound. CH3, C double bond O, then CH2, C double bond O, then C2H5. I am showing here. Sometimes it is written as CH3, C double bond O, CH2, C double bond O, ET. ET, as we know that the acronym of that ET is a ethyl group, means C2H5. Or sometime it may be written as like this: CH3, C double bond O, CH2, C double bond O, then O, CH2, CH3, like this. So don't get confused. There are the various ways of showing that organic compound, but one thing you should remember, whether these contain CH2 group. Look at here, if you observe this structure carefully, what do you find? One CH2 group is here, another CH2 group is here. Now which CH2 group is act as an reactive methylene group? Here oxygen atom here is a methyl group, and therefore this CH2 group is not a reactive methylene group, but this CH2 group is a reactive methylene group or the active methylene group, because it present in between the two electron withdrawing group, which is a carbonyl group, and therefore this middle one is known as a reactive methylene group or active methylene group, and this compound is known as a reactive methylene compounds or the active methylene compounds. Now why different names are given to this compound? Look at here. If you see here, ethyl acetoacetate, here is a ethyl group is there, and therefore ethyl acetoacetate, this. Now acetoacetic ester, look at here, this is a acetoacetic and this ester group are there, this one, and that's why it is called as acetoacetic ester. And now beta keto ester, why it is termed as a beta keto ester? Remember, here are the two carbonyl groups are there. If you remember, as a chemoselectivity, one term is generally used in a chemistry, that is belonging to as a stereochemistry. Chemoselective means the organic compound which containing as a multiple functional groups. Here in this structure there are the two functional group, one is a carbonyl, another one is a ester group. But if you look at two carbonyl groups are there, two functional groups are present. Among these two, one is reacting with, one has greater reactive toward the nucleophilic reaction here. Here, if you compare the reactivity of these two functional group, you will find keto group is a more reactive over ester group, and therefore this, if you want to reduce this into as a alcohol, first you have to protect the carbonyl group, and protecting means mask the particular functional group, treat with the suitable reagent, and after the desired transformation or the conversion, you can deprotect the group, you will get the desired product. So in this way we can carry out or we can perform the reaction over there. We are not going to go into the detail of that, only remember these are the various. Then diethyl malonate or the malonic ester, the structure of that ETO, then C double bond O, CH2, C double bond O, OET. ET means ethyl group, everybody knows that. Remember here there is a once again CH2 group is present in diethyl malonate. Look at here, one ethyl group here, another ethyl groups are there. So two are there and therefore it is known as a diethyl group malonate or the malonic ester. You can remember these different names of those compounds, but here cyanoacetic ester. Cyanoacetic ester means cyano group is there, then CH2, C double bond O, OET. This compound is known as a cyanoacetic ester, then which also containing this CH2 group. Look at here, there is a CH2 group and therefore it is a reactive methylene compounds. Now malononitrile, the structure of malononitrile will be here CN, C double bond O, then the structure of malononitrile will be not this one, CH2 group here, CH2 and Cn. Look at once again, CH2 group is flanked between two electron withdrawing group and therefore malononitrile also has this. So all these examples, diketones, ethyl acetoacetate or acetoacetic ester or beta keto ester, diethyl malonate or malonic ester, cyanoacetic ester or the malononitrile, these all are the example of reactive methylene compounds. These are the name of that. And the electron withdrawing group, just now we have seen some of the example of electron withdrawing groups are here. We have seen what do you mean by the electron withdrawing group or the electron attracting group, EWG. For example, maybe as this one COCS3 acetyl group, or maybe COO-KT ester group, or maybe as a cyanide group or nitro group, etc. These are the examples of electron withdrawing groups. I think these are the enough introduction we have seen, and in our next lecture we will discuss about the synthesis of or the preparation of Acetoacetic ester are the ethyl acetoacetate or the beta keto ester. I think with this let us stop today here. Remaining we will discuss in our next lecture. Till then, have a nice day. Thank you.